I'll not bore you, I would say, because since it's the last talk. And what I've done in this case, as Gautam mentioned, will be around like a comical journey around all sort of features that Ruby has to offer. So before start, I want to understand like how many of you really like comics growing up or still likes those comics to keep them and read those. I guess few of them. What happened? Yeah. Yeah. So since, as Gautam mentioned, that we are going to have a comical journey. So the topic, as you can see, like topic name is Harvey Dent's dilemma. So we are here going to understand, like, since Harvey Dent denotes like the good and bad side in one person. So that's what sort of things we are going to explore about Ruby. So before starting about, yeah. So before starting with the talk, let me just introduce myself. Myself, Vishwajit Singh Desurkar. I have been working at Simply Smart as a principal engineer. So what does Simply Smart do? So Simply Smart, as name suggests, it's about making simple things smart. Like whatever smaller stuffs, like as you can see here, the screenshots and all the sort of things that are mentioned here are related to a water management system. It's a very simple aspect of our lives, but it's also a crucial aspect that one should always think about and to how to manage it efficiently. That's where in these sort of domains that we work in. So starting with this one, what our question for this evening is, will these features will destroy Gotham or will it save it? So starting with comics, we need to first understand the narrative of the comic that we are going to be part of it. So a Ruby code base will be analogous to a Gotham City, and yeah. So there is an issue at Gotham or a Ruby code base, I would say, which is related to mysterious performance problems has happened at the Ruby code base. And Harvey Dent is about to find out who is responsible for these sort of problems or who could be responsible for these sort of problems. And as we say, every feature can act as a hero or some has some sort of villainous side to it. Okay, guys, let's flip the coin and start with our talk. So our first feature that we are going to explore is frozen strings. Yeah. So most of you might have read that with Ruby 3.4, it has been like a compulsory feature with like all the strings, literals, and all will be by default frozen state. So what are actually a frozen string literals? So frozen string literals refer to that we make every literal or a string sort of thing immutable in nature so that they cannot be modified. What it impacts is that it will impact that already those memory allocations will get allocated for that particular string, and in future, if there is any initialization to that string, it will reuse that memory allocation instead of reallocating it again and again. So let's explain it, let's understand with the simple example. We are just declaring a sample string and then we are appending it with another string that is a hello word. In this simple case, it will work that it will allow the mutation of the string. But what if we just add this sort of magic comment? It will raise an error that the hello string that we have declared, it's in a frozen state. You can't just mutate it. But this is a simple example. What is the actual use case of this sort of thing? So for example, we have a auth logger class which will just logs the class, like how whenever somebody logs into a system, it will logs that this particular person has logged in with the message that that you can see on your screen. But as you see, I haven't done anything. It will, and if I try to execute for 100,000 times, it will allocate this many objects for this amount of small code. I just initializing one string here. What if I just change it with a simple magic comment? Will it affect something or not? I would say, like, let's understand like how much it can affect, because as I earlier stated, it will affect as a memory. It's a memory optimization tool for us. As you can see, the total allocated objects are drastically reduced to around like 60% lesser than the original one. By just making a smaller magic comment, it can impact that much. But does that mean, like, as I earlier stated, there are so many benefits of this thing that it removes most of the memory allocation overheads. It can avoid unnecessary mutations in the code, and also eventually, since the memory allocation overhead is lesser, it helps our compiler as well in result. But what if somebody tries it for a dynamic string? Will it work? So let's understand this example here. Like we are just tracking the user activity here. Since the first example is related to logging the user logins, I've taken the similar example here. We're logging a user activity here. But in this case, one crucial aspect is here we are dynamically adding user IDs and event type here. So every time there will be a dynamic new string getting created. At the start, you can see that there are similar amount of objects getting created, but since we have asked our Ruby code to frozen those strings, it will bypass the GC for a quite a long time, considering that it will be useful in the future. And it can make to a disastrous way. Yeah, so as I said, only fools freeze what should float, right? So guys, I need your help in this case. Like I rest my case over this particular feature. What do you guys feel? Is it a hero or a villain? Hero? You can just raise your hands if you feel this is a hero. Yeah, okay, great. And how many of you feel this is a villain? Okay, there are few, so we can say that majority are moving towards a hero sort of thing. Let's move to the next one. We are into like, since earlier it was memory optimization, now we are talking about speeding things up. That's where the memoization will keep in check, or I would say like that comes into the picture. And so what is memoization? It's nothing but like we are storing predefined calculations in our system as a caching mechanism. How it can help? Let's see with one example, a simple example of Fibonacci series. What we are doing here, we are memoizing that whatever the outputs or the results we are getting from this function, so that in future, if, for example, somebody pre-calculated fifth element of a Fibonacci series or something like that, and afterward, somebody again tries to calculate it, it will not recalculate it, it will fetch it from the cache and then respond to it. How it helps? So I'm just adding one example as well. That was a primary example of where we can use this sort of feature. We can either use, like in this particular example of product details, we can see here there are two crucial calls that are happening here. One is calculating the price, second one is checking the stock. In this case, we can memorize these ones, and eventually we can save a lot of time. I would say like we can avoid a lot of recalculating certain stuffs, because if, as you can say, like check stock can be performed by so many people parallelly, and at most of the time it can be at the similar state. Yeah, so what are the actual benefits of this? It caches the expensive database calls. It reduces third-party API calls. As I earlier said, if you know there are multiple similar type of API calls getting called, you can cache those calls as well. It can eventually improve the response time, because it is not recalculating it, it's just fetching it from your cache memory. And in result of all this, it eventually reduces the server load. But what if somebody says like, I will cache all the results that I have? Will that work? No, right? So we know that it can go into memory bloating. So what we can say, can we use this feature, or will it be like useful for most of the cases? Will it be a hero or a villain? As I said earlier, you are going to be a judge and jury of this question. I'm just resting my case here. So what do you feel, guys? It is a hero, okay, or a villain? Okay, there are few with villains as well. Yeah, sorry. Yeah, so moving on, as few of speakers has already mentioned monkey patching here. So I'm going to just brief you with similar sort of case here. So as we say, like with monkey patching, you can rewrite the rules here. But is it always fun, or is it going to be disastrous? For example, if somebody wants to rewrite a rule for a class of a string, simple, right? We can just we can just open a class and we can write a new function called shout, and we can just upcase it, and then we can use that function in future. It will be useful for whenever we want to, as a readability, we want to shout that sort of strings to someone. But what if somebody tries to mess with, like by overriding certain basic function of our code, like this one, a simple function of array, which calculates the size of an array. What if somebody just adds 1 to it? Every time, whenever the size gets calculated, it will add 1 to that size and it will return back to it. It can eventually cause into a disaster state, because everybody will be like, why this is behaving like this? Because every time you are getting just +1 into this case. But conflicts, so it will raise into too much conflicts. And sometimes with this power, there are so many chaos can happen to it, right? So again, as I said, monkey patching, earlier explained as well. What do you guys feel? Is it a hero or a villain? Yeah, most of the people are saying villain. Yeah, then there are two. Yeah, that's quite a heavy villain, I guess. Yeah. So as we say, as we are moving towards these features like frozen string literals, then memoization, now monkey patching, what's next? Or already talked about, topic of today, metaprogramming. One of our speakers gone through a lot of this thing, and entire talk was based on metaprogramming, and this is only a small sub part of it. So yeah, so what are, as I said, what is metaprogramming? What sort of things we can do with metaprogramming? There are a lot of things we can do with metaprogramming. Already, one of our speaker, Chaitali, already explained a lot of things about it, but am I going to explain again all those things? No, because I can't. It's just a subsection of it. So we are going to focus upon instance eval here, which allow us to manipulate objects, and there's some secrets, or it can allow us to recalculate an instance eval. And in Chaitali's talk as well, I have seen people getting like, is it a good or bad thing? And that felt me like, really I did a great job to have this feature here, because there were some conflicts with this one. So as we said, instance eval gives you power to access behavior of that object, and you can manipulate that thing at the runtime. With that gives you a flexibility that if you need to perform certain action flexibly at the runtime, that can be useful for it, and it's a powerful tool to do. As one example, as I mentioned here, a web server. If you want to dynamically initialize all the configuration of that web server, you can actually do it by instance eval. You can manipulate that objects, and you can reinitialize those things. But since, as I said, this gives a lot of accessibility, can it proven to be a liability as well? What if somebody just sends this sort of malicious input to it? You can just initialize as host as localhost, and it just performs rm space -rf to your server. So it can just break your system completely, because RMRF, you can just remove it, right? So as I mentioned, like since we are able to, that gives us a lot of power. Along with that, it can possibly result into a debugging nightmare, because since you're performing so many things at the runtime. But so as I said, it can perform in Chaitali's talk as well. There is a quote that she has mentioned: with a great power comes great responsibility. So does this great power can be futile for a hero, or can it result into a villain in this case? What do you guys feel? Is it a hero? I guess. And villain? Sorry. Yeah, so I guess there is a mixed signal here, because while discussing with metaprogramming as well, I often get that Ruby developers are professionals, and there are who are proficient in Ruby can use this feature. Yeah. Yeah. So moving on to the next one, like as we all know, like there are so many new features coming up every time that Ruby offers. So let's dive into some of the Ruby's new features that are quietly a new one, not just optimizations, but started as a new thing altogether. Yeah. So as I said, there are so many new features that are in market. We are just going to scratch some surface out of it. So starting with, Ractors. As those who have read all of like some sort of things related to concurrency and all, those people know that even though there is a threads, there are other things, GVL come into picture, and it doesn't allow you to actually do any parallelism to it. And that's where the Ractors come into picture, because it kind of bypasses all the GVL for it. And I have given just a small example of calculating a sum in a parallelism manner that can help to improve your performance. But is it too soon to say? Because it can arise so many problems, because it's too soon. Because whenever I discuss Ractors with people, there are like, we have never used it like in some actual systems where we can evaluate how it actually performs the parallelism, and is it better than the current solution that we have. Now the second one, the endless method. Like those who have been like tried another languages as well, there are so many single line methods. Those who can go from like just initializing all those methods, like some in Python Lambda and all. Like for example, so this is a typical definition of raised to power. It is just accepting number and power, and is giving a power. Now a number raised to the power. It can be redefined as this way without an end to it. That is an endless method to it. So this is a new thing that introduced in Ruby 3. But as a Ruby developer, we always loved our block-based structure, right? And it kind of breaks that block-based elegance of our code, which actually can you can easily read our code that this is the start of the block and this is the end of a block, but it breaks that thing, right? Now, how about argument forwarding? Those who have tried some sort of scripting here, they might be familiar with this term, that you can directly forward all of your arguments from one function to the parent function to the children function. For just one simple example here, that I'm just accepting, I just defined two functions. One is process message, which is in a private state inside the private block, and another one is the main lock function, which gets called from outside any can call, and it can send some sort of parameters to it. But since we are using argument forwarding here with the 3 dots, we are forwarding all the parameters that we are getting to eventually the process message to it. And it's processing at the end of it, but although it gives us like, it just reduces all sort of parameters sending again and again and again. But what if somebody wants to read and understand your code block? You have to go again backward to where that particular parameters got actually originated from it, to understand if there is actually an issue or what happens, how these things actually works. So it's kind of new to these things, because these features do provide some sort of, I would say like the capabilities might be fruitful in the future, but right now it's too early to say about these sort of features. Yeah. So similarly, Ruby 3 is these features, because there are other features as well. What do you guys feel? Is it a hero? Yeah. Or it a villain? Okay. So I guess there are mixed kind of feelings here. So let's summarize what we have discussed here. First, we have discussed that frozen string literal are good for constants, where there are no mutations going to happen. You understand your code, and if there are no mutations going to happen, you can leverage this frozen string literal. But you should avoid it using for dynamic strings. Similarly, although speeding of things is good, but you should also understand that it should not bloat your memory. Then monkey patching, it can solve your problems, but it can really goes into a chaos altogether. Similarly, metaprogramming, as I earlier stated, it's, as I mentioned as an expert, and mentioned earlier, that it's for proficient people. So you need to understand all the things well to understand. You should always have that barrier ahead with that responsibility to take, and then you can start using these sort of features. And the last one, these features are good. We have to looking forward to it, and we should looking forward to it, that which one of these can shine for us in the future to help us to do our things better. At the last, I want to just mention one thing before ending my talk. All these images for comics and all those things, I generated it from GenAI using openart.ai. So they helped me a lot with this thing. And that's why I mentioned them. Other than that, there is a bit.ly link for Ruby India. Those who have been to offline meetups or some sort of online meetups that we organize, that's where we connect. You can please do join this thing, join this Slack channel. This is a short bit.ly link for it that you can use to connect with other Rubyists around India, and you can join our online Ruby meetups along with that offline meetups in Pune. And lastly, you can visit simplysmart.tech to understand what sort of things we do in SimplySmart. And if you're really interested, you can connect with me to understand how from hardware end to entirely a software end, how all things work and how we handle all those things at runtime. Yeah, thank you.